folks, Assalamualaikum. I'm Mohammad Shahriar Al Mustaqim. So I'm a CNCF ambassador and the organizer of Cloud Trip Dhaka. So what I'm going to start today is the series for Cube Astronaut. Okay, so yeah, my goal should be to create content on the whole 5 certifications on Cube Astronaut, and after that we're just going to go for the Golden Cube Astronaut certification as well. So in total it should be 14 certification preparation, and the content should be available for you, right? So yeah, starting with it, I have a series on Hashnode, so you can just read from here if you don't have any knowledge about Linux, because the series on DevOps, how to become DevOps expert. So you can just come here and you can just learn from here. So from in this session or in this video, I'm just going to start with Docker, not like the Linux. I'm not going to start with Linux. So if you are not skilled on Linux, or if you don't know the Linux commands, etc., it's very important for you to learn those. So this is the series you can just follow. I'm just going to share the link in my description of the video. But starting with it, I'm just going to cover these two, Docker Basics 1 and Docker Basics 2 today. What I would say is 40% would be of the things would be hands-on. I'm just going to show you how to do things and so on, because most of the things are actually going to be, I'm just going to read the blog and I'm just going to show you then the hands-on part. Okay, so this is how things are going to be. So totally focus on the blogs, feel free to read those out, and yeah, let's get started with the Docker. And yeah, feel free to learn the Linux from here and then learn from Docker as well. So okay, so first of all, start this one. So Docker Basics Part 1, that's good. Okay, so why do we need Docker? That's a question. So from here you will see okay, so another thing is majority of my slides would be like from the Code Cloud one. So yeah, kudos to them, so that they made some good content on that, and yeah, contributing to the community. So yeah, let's get started. So the thing is, if you have worked with web server database or messaging or orchestration and so on, you will see, like in general, just for an example, like what we do, what if we are just working with this like web server, whatever, we just have a like for example, we just have maybe a Windows or Linux based or Mac OS or something like that. We just have some sort of hardware infrastructure, and hardware is basically not the OS is the what this Windows, Linux and whatever it is, but hardware is basically like the PC, laptop, whatever it is. So within that we have some sort of OS, which is operating system, and which is basically Windows, Linux and Mac OS. Okay, so in general this is something common for everyone, most of the folks who do have kind of laptop or PC, right? Now as a developer, when you're working with web server, database, messaging, orchestration and so on, you will have libraries, and these things like depends on a lot of things. So libraries, dependencies, you have to install them, you need to have them in your system or so on, right? Because just an example, like for example, if you're just maybe running something like maybe just out of example, like just a moment back when I was recording this video, so prior to that I was working with quantum computing, one of the quantum convolutional neural network and so on. So I was running something. So while running some portion of the code, it was like, okay, this part is missing, right? So that is basically looking for a library. So then I had to import that and so on, or I had to install that. So there are a lot of things, right? These are the things, libraries are dependencies, right? You need them. Now what happens is, if you just if you have a hardware OS and if you have lots of libraries, because you have Node.js, database, MongoDB, Redis and so on, right? Lot of things you do have, and you have to install the libraries and dependencies for all of them, right? So you are not managing them, you're just installing them in your PC or a laptop. So it's something, a kind of matrix from hell, right? So it becomes so much painful. But if we talk about the containerization concept, right? So what happens is, using Docker, what you can do is you had hardware and OS, right? On top of that, if you have Docker, the Docker provides you something like, you have some sort of thing called container. Okay, you might have heard about Docker container or something like that. So you just install Docker. In general, it's like Docker is obviously surely works with Linux, right? Most of the things that is running in the ecosystem is Linux based, but Docker has supporting version for Windows as well, so you can install that as well. But yeah, you should actually do the development stuff, and everything in Linux is far better. Okay, let's just talk about it. So if you just install Docker, on top of that, now you can run containers. Now you can say like, what are containers? So just assume the ship containers. What do they have? They just carry few stuffs from here to there, right? From one country to another. So these containers are also the same. They are just shipping some sort of content from one place to here. So what do they have? So this can be something like, the thing is, for example, the web server. Earlier we had this Node.js, Node.js Express. So it had it has some sort of libraries and dependencies, right? What we can do is, like, you see, earlier we had 4 stuffs, and for them there were libraries, dependencies, and those were not aligned with them. Those were like maybe in the system, but when you need them, it becomes messy. But right now, this Node.js Express, whatever the library and dependency it needs, it will be within this container. So this Node.js Express actually don't need to bother any of these containers. So everyone is safe, and everyone has its library and dependency within them. So what's the benefit? We'll talk about the benefit, but just assume that, okay, they're just coming with whatever. It is like a person is there, and he has like the food and the toilet system as well. So a person needs food and need to obviously go for the washroom and others, right? So yeah, we don't need to bother about him right now, just like that, because he has enough food and he has enough things to maintain himself. Or you can just give any other example, but yeah, just came on my mind, right? But the thing is, yeah, this is like that. So for example, this Node.js Express, now you have just installed that in your Docker, in your system, right? On top of Docker. Now if you think like, okay, I want to delete that, that's good, right? Whatever this Node.js had dependency and library, it will be deleted with it, right? Just like that. But when you are deleting Node.js and whatever it is, the libraries and dependencies were not getting deleted, right? It would have been in the system for a while unless you delete that. So it's good. But is this the same, or is this the only reason why we need to go for containers? This can be a question. Okay, so yeah, in general, like, I also use Ubuntu as well. So yeah, on top of Ubuntu, just like that, we just skipped the hardware part. Maybe your PC or laptop, Docker, and something like that. This container, so just to visualize yourself. Now this is the interesting part. Like, why do we need containers? And yeah, this can be a good question. Okay, so interestingly, if you have worked with cloud computing, which has this concept of virtual machines, or you might have heard about virtual machines via Windows and so on. But the cloud computing, if you're working with cloud computing, you will see those virtual machines a lot, right? Now, if you've worked with virtual machines locally or in cloud, you might see, if we just look into that here, if you just look into here, you will see that what we have a hardware, right? Like maybe a device, and we have a hypervisor. We're not going to talk about hypervisor here, but here are the virtual machines two virtual machines. You see, every time a virtual machine is getting created, it requires an operating system, it requires libraries and dependencies, and an application. So just see, like hardware infrastructure, hypervisor, no problem, OS, libraries, dependency, application. Great. Now if you just look into here, you will see hardware infrastructure, OS, Docker, but in the container we have just application, libraries, and dependencies. So just now forget this part, just look into these four or just two. You see, the container has application, libraries, and dependencies, but the VM has application, library, dependencies, and OS. So every time a virtual machine is getting created, an operating system is a must. So if you just launch a VM in Google Cloud or AWS or Azure, no problem with that, but you'll see you have to select an operating system, like maybe Windows or Ubuntu or Linux based or whatever it is. You have to select that. The containers don't need that because they are running on top of a operating system. Okay, so it makes these containers very lightweight. Now this might not be a very big issue for maybe small projects, but the real world things stuffs are actually, for example, the machine learning stuffs, yeah, obviously those are managed by Kubernetes and so on. When those things are running pods, containers, these things are something, these concepts are something you will learn. Some folks do mix up the containers and pods concept, mix between them, but yeah, they are not same. But yeah, we'll learn about that. But the thing is, we have to manage lots of containers or pods, right? So while doing that, if the containers are lightweight, it's very much better for the company. So you have to think about it. So you see, the utilization, you will see not that much, but the thing is, the size for the containers are within MB or so, and the boot up process takes very less time, so it is very fast. But talking about the GB, you see, it utilizes lots of the memory, and almost the size is almost 3 GB, and boot up process takes some time, so it's better. So yeah, I believe we're not currently in a stage where we need to mention like why should we go for containers, because it's already getting used. It's just to make you understand, like, okay, this is the reason what we are doing. That's the thing. Okay, now the question arises is, okay, so we have been using VM for a while, so should we get out of VM? But here's the twist. The thing is, you can use both of them. How? You see, if you just look into the architecture of the VMs, you see we had hardware infrastructure, hypervisor. On top of that, we had a virtual machine. You see, hardware infrastructure, hypervisor. On top of that, we had virtual machines. So we have virtual machines, no problem. But within that, if we replace the application part with containers, we can accommodate much more containers within them, right? You see, so these containers have been replaced by the applications. So because you see, the dependencies are right now within that, so it is something, you say, like it has become much more better and easier. So yeah, this is how you can use containers and VM at the same time, and much more better. Now we're just going to start our hands-on with this, like how to start a container and so on. And okay, let's get started. So we'll first start with like how to run a container. So yeah, let me start Docker Nginx. For I believe you already know about Nginx. So if you don't know, feel free to just search about it. But let me just remove this one and this one. You see, what's happening is basically it's listening on it. Okay, no problem with it. Okay, what I believe what I can do right now is I'm just going to go for this within a folder. Okay, let's do it with it here. Open in terminal. It's better. Okay, let me just go to your Docker. We're just getting a Docker directory, getting into it. We don't have anything here. Clear this one, and let's just run this. Yeah. Okay, so what's happening here? We'll just learn about it within a while. But the thing is, you saw earlier that I was running, like I did run the nginx server, docker run with the command docker run nginx. So it started running. So the command docker ps-a shows is basically the active containers we do have. Okay, so just look into here, you see we start the process, no problem with that. Then to check the list of running containers, you see we use docker ps. But if we want to see like whatever container we had earlier, by now just want to see the exited containers with the docker ps-a. So just go for here and just search for docker ps. Okay, docker ps, you see it is basically by now you see these docker ps, we using docker ps-a or docker ps, you can see the same container id for the image nginx, although using the image we have created a container. So we will learn about it gradually, but you just need to learn or know about this. You see it started about a minute ago. Status is up about a minute. Okay, that's good, it is up and running. So it is running, and when we use this one we also saw this. But the thing is, it was not like it didn't exit. Now if I press this Ctrl+C, you see it has exited. If I just come up here and let me just clear this for a while, docker ps, you see there is nothing. So the docker ps's main role is to show you if we have an active container running. But if we don't find anything here, we can just use docker ps-a. So you see, now you can see that because it just lists everything, like okay, whatever you had by now, right? And yeah, this is how we can do it. Now let's go for another one. Now for example, now I wished like okay, I just don't even want nginx to be or this container history in my system, whatever it is, I simply don't want it. For that I can just use, obviously I have to use this one, the container id, but here is a twist, that is the container should be exited by now. So we have seen the container has exited. So let me just delete this one, docker rm, then I believe to copy. So you see, if it works properly, it will just return the container id. Now if you just look for docker ps-a, you see it's gone, because even the container history and everything is gone, so we can't track about it. Now you can ask like, okay brother, why this Minikube is out here? So we'll talk about it when we start the Kubernetes one. Many folks call it K-Days, many folks call it Kubernetes, so whatever you call it, but we are going to run our Kubernetes or Kubernetes on top of Minikube actually. Okay, so this is the image obviously needed, so I'm not going to delete that. Okay, now that's good. Now talking about Docker images, we've just talked about Docker images. We can talk about how to remove the containers, but the thing is we can also remove the images as well. So we can ask like what the images are. So images as a whole, I like introduce folks with the image concept. Just like for example, you've gone for a tour to London. Okay, so you have a camera, so you have gone there and you have clicked some photos of you. So image is every time for me something like capturing something and keeping it, so something like that. So the containers are basically consist of images, because it's basically save some sort of components and create some sort of image. Once you run the image, it becomes a container. That's it. So this is how you understand. Now the thing is, we can also see the list of images I have in my system by now. So let me check. Although I have removed a lot of the things, so you see there are lots of images I do have. So what I'm going to do is I'm going to delete everything except this one, so that we can actually practice this out. Okay, so yeah, docker RMI. So you see untagged, deleted. That's good. So interestingly, these are the images you will have if you just follow this whole session alongside me, because I'm just going to do or hands-on this kind of thing, hands-on actually, and run these images, containers, make so many stuff. Oh, sorry, my bad. Let's copy, it should be pasted. Okay, docker RMI. Oh, in the meantime, feel free to share this video with your friends if they want to go for the Docker, or if they want to learn Docker, or they want to go for the CNCF certifications. Okay, so these are the things we will learn today, interestingly. Okay, great. We just have a few more. I believe we're interestingly, you see, this is the latest one. So I am thinking of removing the old version of Minikube as well in my system. There's something might not be sure there for you. Like if you are starting with this video, these images won't be there. So you just don't need to panic. You just don't need to think about it. Just see what I'm doing. You just don't even need to copy this part. I'm just doing it so that we can learn. Now you see, we have just one image. That's good, right? That's good. Now that's good. Now let's focus on the session and let's start. Now if we want to like start or if you want to like for example, we want to run the Ubuntu container, okay, and we can make it sleep as well. Like earlier what happened was, okay, the earlier one Nginx was also running, up and running, but we can start, basically the containers do start, and there are some commands that is given to execute by the containers, but like it is written in Docker file, and that is basically executed. If that is done, the container actually exits. Okay, so this is how things do work. But what we can do here is we can make the containers do some sort of tasks. Okay, so by the end of this video, you will also understand like, okay, how can we also control these stuffs, these kind of things. Okay, just talk about it. So let's start. Like for example, I'm not going to give 100. So we are going to start the Ubuntu container and make it like pause for almost 10 seconds, or make it active for 10 seconds, something like that. Okay. Ten is very less, I believe. Sleep 30. So what happens first? Just you see the process, because now right now I don't have any image except the Minikube. So what happens is, Ubuntu is a container I'm just looking for. So this container has Ubuntu image. Now what is happening is, this library /Ubuntu is basically meaning Docker Hub. There is something called Docker Hub. So it goes there and looks for Ubuntu official one. If it finds out, it just downloads this one. You see, downloaded newer images for Ubuntu dash colon latest. So this latest means tag. This is some sort of tag. Okay, there are lots of versions. Latest means the latest version. It is not specified here, but whatever the latest version is, latest, this word actually means that. Now you see it after the status, it was like paused for a while, and now it's like okay. Now let me just look for, you see, it's not working because it paused, like it was there for 30 seconds and then it died. So I'm going to do another stuff, but before that let me check this one. You see, again, if we use docker ps-a, so you see the container ID of Ubuntu, no problem, but you see the command we used. This was a command, and it found out that this is a command, so it is expecting to like to be ended, once it starts, it should be exited after 30 seconds. So you see, created 53 seconds ago, and you see exited 22 seconds ago. So if you just minus them, you see it is like 31 seconds, right? That means once the 30-second period is done, on the 31st second it exited. So this is what I wanted to do using the Ubuntu, Ubuntu image. Basically we created Ubuntu container, and this container was there for 30 seconds. Okay, and this is the command we use, like okay, just be there for 30 seconds. So right now what I'm going to do is I'm going to make it or I'm going to use sleep 50 seconds so that I can show you. Okay, hey, you can see it's active right now. Okay, let me just clear this one. Docker run Ubuntu sleep 50, right? So if you just go here, docker ps, you see it is active, right? And it has not exited. You see it's still blinking. And if you just go here in the same, you see it is still working. It's a 5 seconds ago it was created. So once the 50-second period is done, it will exit. Okay, this is what we're doing with the container. We're just saying a container like follow this command of ours. Okay, let's wait for that, and that's good. Let me just check again. You see, 33 seconds ago status is up 33 seconds, so it is up for 33 seconds for the past. So we have almost 17 seconds left. That's good. It just feels so good, right? So you can just visualize it. For example, I am thinking maybe this is not a good for the view. Okay, docker ps, I believe, yeah, it's done. It's gone, already gone. Yeah, it's gone, because yeah, the last one was 48 seconds and status was 47. Now you see, using docker ps, it is not there. That means the container is gone. It is not running. Now how can you know, like, okay, when did it exit? So you see docker ps-a, if you go here, you see it was created about a minute ago, exited, sorry, my bad, that was the earlier one. Oh no, my bad. About a minute ago, and it exited 32 seconds ago. That's interesting. Okay, oh yeah, we've just come here after a few seconds, right? So the time has passed by. So yeah, it exited after 50 seconds. That means obviously about a minute, 60 plus. So it was around 90, 53. Oh sorry, it was around 82 seconds when we entered here and we checked about this one. Okay, let it be. We're just making it much more complex. It is not. Let's just look for it. Now let's go and talk about few other stuffs. Okay, so while we were creating a container, we had to deal with the images as well. So you can also pull images, we can execute various containers, and there just use this one you can see here. Okay, right, no problem with that. Also interestingly, as I was mentioning, like we did run the Ubuntu, but what we did was we used the latest version of Ubuntu. right? We didn't have to mention, we don't need to, we didn't mention anything actually. So but what we can do is basically we can specify what version we do look for example, docker run ubuntu and colon, and then we mention this one 20.04. So you can just do that. For example, you can just do that. Also there is some sort of command called -t when we want to like execute a container in the backend, or like we want it to be running in the backend. Okay, we can just use docker run and then -t. So let's go for that. Let me just copy this command. Right. Oh, sorry. Okay, let's just go for that. Okay, so here you see what happened is it is not blinking. It is working for the you see it is working, and it will sleep after 100 seconds. But you see docker psc, it is working, right? But it just behaved like it exceeded, because when you looking when you just mentioned -t, it is working in the backend or something, like it is working in the it is working, but just don't need to bother about it. You can proceed. That's good, right? You just don't need to. Earlier what we had to do is it was blinking, we couldn't write anything, but we can do right now. Okay, so yeah, this is good, but after 100 seconds it will exit. Okay, that's good. Just not wait for that. Let's move on. Also there are a lot of commands, like you see -i and -t. How, when can we use this one and so on. I'm just leaving it to you so that you can try this one. Okay, I've also used these or I have attached these screenshots as well. Now let's go for the port mapping one. So this is interesting. Okay, so what happens is, for example, let me just zoom in a bit. So let's start and talk about the port mapping. Okay, so what's port mapping? Assume that you have a container that is running on 5000, okay, on this port. This is web app, okay, some sort of, we have earlier talked about this, some sort of containers. So assume that this is a container, you start here, this is running on, and you can just get access to this container on 5000 port. Okay, that's good. For example, this code class web app, it is running on this. Okay, no problem. But how can we get access to it? Because maybe this is a Docker host and maybe a laptop or whatever, within that this is the web app. So how can we get access to it? So what we do basically is this Docker container has its own some sort of IP, okay, and on top of that it has a port where we can get access and get access to the web app as a whole. But still we can't get access to it properly, because we also need to know the Docker host IP as well. So what happens is, what you can do is, when you are kind of using or when you are running these kind of containers, what you can do is you can just mention these Docker host or whatever it is, its IP addresses port, one of the port where you want these port to be linked. Okay, just understand what's happening. So this is the container, it has 5000 port, and this is your system, and you are allocating one of the ports, like port 80 for example. You are saying like, okay, this should be connected with this. Now you can ask why. Because in general you'll see Docker host, within Docker host we can't enter in general from outside, but we just can get access to the Docker host, or if you are just running the terminal within the Docker host, we just don't need to go for this specifically. We can just go for this Docker within. If we just run the terminal within here, and if you just look for this 80 port, we can just get access to this one. This is how it works. So this is called port mapping. So what we can do is we can just connect this port with this port. So when you're running, we have just seen the run command, docker run something, and right now if you just look for docker and then -p and then mention this host port and then the container port and then mention the container image, or so that we can create a container. So this is how it will work, and then we can easily get access to it, and port mapping will be done. Now what's the benefit? You see, if we have lots of containers, for example, we have like a web app, 3 web app containers and MySQL. Now interestingly, what happens, you see, these web apps are by default, like when we were designing, assume that they were mentioned like they will use 5000 port for in their container. This web app, every web app is connected, like they can be accessed you via this 5000 port. But like you see, 5000 port is something the same, right? Again, MySQL is again 3306 port. This is also for them. Now, if we can connect these 6 on 6 different ports on the host, it is better. Now you see, this is connected with 80. This is connected with 8000. This is connected with 8001. This is connected with 3306. This is for 8306. Now using now using these ports, we can just get access to these containers. Great. So when we want to create this kind of connection, or when we want to think of connecting or get access to the containers, we have to run using port mapping. Okay, so this is how things do work. Again, interestingly, there is another thing called volume mapping, and once we're done with this volume mapping, I'm just going to show you how we can do it. Okay, I'm just going to do a hands-on, so that will be interesting. You can just learn about it. So what is volume mapping? Just like the port mapping, we'll connect some sort of volume from the host with this one. This is the container's volume. So when we are creating the container, or every container has some sort of address where the files do remain. Okay, so for example, this MySQL container has like dash like this var slash lib slash MySQL. So here is what the volumes are here. Now what if you start this MySQL and you see is some sort of database, right? And you started storing some data. Now mistakenly you just delete the MySQL container. So what happens right now? All the data that was there will be lost, right? That's painful. But if you have some sort of volume mapping done, what will be there? You will get access to the data because you might have connected to a local volume space. Okay, for example, this is, if you just delete it, it's just gone. So what you can do is, for example, like /opt/data directory, whatever it is, you just don't need to follow this format for sure. You can just connect. Sorry, you can just connect to any folder, maybe just within the folder. We'll just show that. I'm just going to show that. So you can just connect this volume to here. So whatever it is now, once you are running, once you are storing the data, that is basically going to this volume as well. So if you just delete this one, and later when you create another MySQL container, and while creating that, if you just connect with this one, automatically this container will get access to the earlier data, and you can also see the whole content. So this is the concept of volume mapping. So we are just going to see that right now. So how can I do that? So let's start, right? Let me just move this one here in different systems so that we can just start. Okay, let me just do this clear. So right now, where are we? We're like some sort of like home/mythosharia/desktop cube astronaut series, and then /docker. Great. So what I'm thinking is maybe we can create a data folder. Data. Okay, and let's go for the data folder. Now let me clear this one and let's see the directory. You see, now we are within the data folder. Now what we can do is I can basically create this Docker container one, and sorry, I can just create the MySQL container, and while doing that I'm just going to set this volume mount, and this is how it's going to work. So let's just go for the blog. The blog, if you just look for that blog particularly, you'll see that I've just written the codes. So yeah, let it be. So I'm just going to share it right now in our screen, and we're just going to work with it. Let me just check from the blog. Yeah, let me check if this is working properly, because I'm not sure. Obviously this is not the format. But let's see if this works for you. Desktop Docker Kubernetes, it should be. This format doesn't follow. Here we have to write down this one. Let's see if this works, the format. Yeah, it seems working. So what is happening right now? What is happening is, you see, if you just look for the command, I don't think you can see that properly. We have just written that here. That is if just let me just share this block here. It is okay, sorry, here. So you see, we're just saying docker run, then we're saying okay, the database name, this container name should be MySQL-DB. Okay, great. Then we're also saying like okay -e. This is basically environment variable. We are going to talk about it later on, but because the MySQL containers, if you just look for that, this is a database, so you need to have password, so you have to set that. Also within that we have the database name called testdb. Okay, great. Also we are saying like okay, the username or MySQL user is test user. We also have passed the password. Okay, and -v, this is our volume mount, right? So here you see, first of all we are saying like okay, this is where I'm in right now. Like this exactly not the same obviously address, because I've changed it, right? You have to change your like according to your location, file location. Okay, you just have to mention that, and then you have to surely mention this as well, because this is exactly where the data remains for these MySQL containers. Then we have also used this port mapping as well. So this is 3306 within here. The container will be available, and I'll mention like okay, in my local system I'm also allocating 3306, so connect both of them. So it is port mapping, and then -d, and we know when do we use -d, and then we are also saying MySQL. This is the container you have to we want to use, or this is not container, basically this is image. I just made it I just wanted to make it easy for you, because you just need to specify the image name, and it basically by default uses the same image name to create a container. But here you see we have specified the name, so this time it will use MySQL image, but the name should be MySQL DB container. Okay, and we have also mentioned the version of MySQL image, it is 8.0. So you have seen by like so far whatever we have learned, we have just used it. So let me just move it here, and great, you see downloaded newer images for MySQL. So if I just want to see the Docker images, now you can see Ubuntu latest, because we were using the sleep command, right? So the latest one was there. As we didn't mention the specific version, the latest is there. But when we mention about the specific version 8.0, you see this specific 8.0 version is there and it is used as tag, right? So yeah, that is it. So now we have just created the we have just created the MySQL DB container using MySQL image. Great. Are we done? No, we're not done yet. So we have just created like port mapped. We have just created the volume mapping, but we need to have some data, right? Then we can just verify, okay, we are just working it properly. So what I'm just going to do is right now, use this one. I'm just going to connect to my container, yeah, via this exec. We have also talked about the execution one, and I have also mentioned IT. You have to use this IT, and this is your task. This is your homework. You just have to like see how we can do that. And using -h, I'm just not going to talk about -h here, and -e is user, and yeah, p test pass. So you have seen already, this is the password, and this is the test db. This is our database name. So we just connect with our connecting to our container and within the database, right? Okay, great. Now what can you see? You can see we are already within MySQL. Great. We have entered into our MySQL database. Now what we can see, we can just look for the databases we do have. So I've made it easier for you so that you can just copy paste the commands from my blog. Paste. Show databases. You see we have three databases: information schema, performance schema, and test db. This is the db like specific test db which we have created when we were just if you just look into here, yeah, you see MySQL database. We have mentioned like, okay, let's create this database. Now I'm eager to use our database, right? Use test db, database changed, so it is now within test db. Great. And now let's create a table. Okay, and I'm not going to explain what it is, basically like what this users, or what kind of variable name it is, what kind it is, and everything, because you can just Google it, or you can just search in the AI, like make me understand this is okay. What I'm going to show, or what I'm going to say is, okay, we're just creating a table. Table has some sort of columns, and every column has some sort of content. So, and every content has some sort of type, this kind of thing. So we'll just see within a while. You can see some sort of image, and you'll understand, okay, what it was. So we have just said, okay, I'm just going to create a table. It will be named as users, and the column names and data type should be something like that. Now let's just enter or insert our data. Paste. Okay, you see I have entered few stuffs. Now this is something I can make you understand, like, okay, I'm just said users has name and email. Great. And the values for name and emails are Alice, and Alice is male, Bob and Bob's male, and Charlie and Charlie's male. Great. That's good for all of the stuffs. Now what I'm going to show is I'm just going to run a query so that I can see all of them in a visualized way. So right now you see select star meaning everything from users. So every data we have in the users, just create this one. So you see Alice, Bob, Charlie, and their male, right? And created at this type. So everything we have in the database is out here. This is very important for you, right? To understand, like, okay, this is the data we have, and yeah, this is what we are expecting once we delete this database and container and create another one. Okay, we have to understand that. Now let's just exit from our database. Exit. You see, it's like exit. Bye. Great. Now this container is still there. Just to verify, docker ps. You see, this is still running. But the thing is, it's running because, yeah, it is designed so that it should be running, because we can use it anytime we want. Some images are not designed in this manner, no problem with that. But my goal right now is to like stop this one. Okay, now what I'm going to do is I'm going to stop this database like this. You see, this is the image name, right? And we have to, what I'm going to do is I mentioned the container name. This is the image, this is a container name. Using the image, the container is created, so we can just mention stop and this, or the container ID as well, no problem with that, because this was the name, right? So yeah, it stopped. Now let's verify. You see, there's nothing. That means this container has stopped. Now what I want, for example, now I also want to see, okay, if it exists, if it ever existed or not. So you see, the list is here, right? This is the one. So I'm also thinking, let me delete this for like for lifetime, right? We can do that. We just copy this container ID and just say docker rm this container ID. And see right now, like, okay, now let me just use it, ps dash. Okay, oh sorry, my bad. But, oh yeah, okay, right now you see this is not here, right? That's good. That means we have just successfully deleted even from our system. But right now I'm just going for I will just go to another terminal in the same location, because I just don't want to create messy stuffs out here. Let's just go for another one, so that I'm just going to return here, and I'm just going to show you exactly if the data is similar or not. Okay, let me just clear out here. Okay, now you need to understand what's happening. That is, we just created a container and we just also connected with a local system. Then we added some input or data. Then we just deleted the whole container. It is not even existing in our system. That's good. Now the thing is, the data should be there, right? The data which we just entered, like the Alice and Alice's mail and Bob's mail and so on, right? Okay, it is theoretically it should be there. Now let's just create another container. Okay, docker run dash, this name should be mysql dash db underscore db underscore new. Okay, volume mount is exactly, we're just going to change the location. Okay, and this is important because we have to mention exactly the same location where earlier we actually had this container. Just to understand, let me just give you the here, just understand here. So this was the container, and this was this is where we have maybe the data folder we just created. We just connected with it. So there is a connection. So once we decided to delete this one, it is gone, totally gone. Now if we want to create another container, surely we need to connect it with this so that we can get access to the data we just entered, right? So this is what I'm going to do. So here, if you just look into here, just for sure you have to change this location. Now you may ask, like, why should we? Because surely this is the location where our file is. So I'm just going to create another one. So we're just within that. Let me just write pwd so that print the working directory. So it just writes it, so that I just don't need to write it out. Okay, here I'm just going to paste it out. Okay. Okay, that's good. Now you see docker run, then name. The container name should be something like that, mysql underscore db underscore new. The volume mount is exactly the same location where we did mount the earlier container, the MySQL container, and this is the same, and this is the root password. Okay, and this is the port mapping. And as the container is totally gone, this local system has this port free right now. But if we wouldn't actually delete that container, what would have happened? We should have like, we could actually select a different port, maybe 3307 connecting with 3306. No problem with that. But as we have deleted, now we can just reuse this node or okay, port. Okay, and then we're just running it in the backend, and MySQL dash colon 8.0. Okay, now here is the interesting part. Let me just go here and let me see if the image exists or not, because we have just deleted the container. Yeah, here you see the MySQL 8.0 image is existing, and like for example, like just I might have used this 3 weeks back. Okay, no problem with that. That's good. Okay, but this is not exactly what it means, because we've just started it with just a moment back. But this is basically about the Docker Hub image and so on. Okay, so you just don't need to bother about it. But this time what happens is, earlier when we started that container, it took it time because this particular image was not in my local system. It started downloading. But right now, as it is existing in my system, it will take a very less time. You see, press enter, you see it is done. It just didn't take any single time, because it just verified, okay, this image is existing, and okay, it's done. And the main purpose of -d was to like running this MySQL in the backend. Basically, this is why it is running. Now, what we're going to do is, right now, we're just going to see like now we have already created this one, right? I'm just going to see. Now I'm going to connect it with our system. Okay, so here you see the execution command, and with the new database and the MySQL, obviously this is where the TCP protocol is working. Test user, pass select from test user. So as we have connected it properly, we're expecting some sort of data. You see, that is exactly Alice, Bob and Charlie. It's created like 1942. Just go here, right? Yeah, it's exactly the same, right? No. Yes. Okay, this is it. Like, we have successfully seen, like, okay, we have created another container and created a volume, okay, what do you say, port mapping, you can call it volume mapping, and or binding, whatever it is. We'll learn about binding later on. But the thing is, yeah, this is it. We have successfully just got access to our data. So right now, after that, what you can do is, like, you can just remove this one. For example, I just do prefer, like, see, like, okay, if it is running or not. You see, it's running. And what I'm going to do is select this container ID, docker rm, then this. Oh, I haven't stopped it, right? Interesting. I just forgot. Paste it. Yeah, done. Now we can remove this. Great. If we just let me just clear this one. Okay, it's gone, right? It's the container is not there. Like, we can also delete this later on, but no problem. But interestingly, like, this container is gone, right? So the node is free right now, or port is free, basically. But interestingly, what I want to do is basically is this one. If you just go for the Docker, and if we go for the data within the data folder, we just we basically connected it within the data. If you just go to the data folder, you see there is a lot of files that was created, and those are like, this is a locked. We can just go for that. We cannot get into it. And if you just want to delete this one, move to trash. You see, you can't, right? So the best way is to delete this thing via the command. So what we can do is we can write this command like sudo rm, then force it, and then we can just mention where it in the Docker file for sure, within the Docker. So we can just mention, I believe, the data, and then I have to mention the password. I'm not sure if I've just provided it correct. Oh yeah, great. Now if you just look for this one, we can't see any data folder out there. So if you just go here, you see within Docker we don't have anything. So yeah, you see Linux or Ubuntu is so fast. Yeah, this is one of the reasons. Now let's go for the theoretical part again. So I believe once we have done with it, or once we have worked with it, if you have followed the whole thing with me, and if you have just created this one, you will, or by now you have learned a lot. Creating a container, and it may like executing commands with it, running it in the backend, and so on, or the background. Now you can see. Now let's start with how can you create our own image. Now, as we have learned with, like, we can call, or you can just look for images and create containers. Now we have decided, like, okay, let's go for an image. We want to create our own image. Why not, right? Why not? Yeah, that's good. Why not? So let's start with this. So what's the process? Now I'm just going to do the whole process for sure, so that you can also learn about it. But what happens is, just understand what these images are. So as a whole, right now we're just thinking of less containerized simple web app. There will be an web app. The code will be kept in this app.py. So here, this is where you can just follow this one, this Mom Shells code. Also, I have also like this is exactly what this one was, this theoretical, but I have also created my own as well. So you can also follow this one as well. So if you just go here, here are the codes. That's a different one. You can also look for that. That's totally new. So if you can also create this one. So yeah, it's totally up to you. But yeah, let's just look for it. So for example, there is a within the app.py, there is some sort of code, and that is basically simple web app code, and where Flask was used. Okay, and no problem. We're just not bothered about the Flask app. Okay, let's not bother about it. Let's just think, okay, we have some sort of the app. Now here we have, now then what we have to do is we have to create a Docker file. Then we have to mention few things, like what or which operating system we want to use in the first line from Ubuntu. That means we want to use Ubuntu. Okay, then we have to mention, like, update the apt repo, install dependency using apt. So these are the two commands we then use. Then we have to, like, install Python dependencies using pip. So then you see, run pip install Flask and Flask MySQL. So these two we start with it. Then we copy source code to opt folder. So that is an interesting thing, because earlier we also saw the opt, right? OPT. So basically you will learn, like, later, like there are few typical folders names which developers do use, because this is some sort of practice we do use. Like, this sort of folders, if you want to keep some sort of data like this, you need to use this kind of folder or something like that. So OPT slash OPT, this kind of folders are basically used for the development purposes. Okay, so what we are doing is, what copy then dot, then this means is, assume that we are within a folder where this app.py is. Then we are saying copy dot this. So if the file is out there, like app.py, it will just copy all of the stuffs to this location. Okay, we'll see that later on. I'm just going to show you. No problem with that. Just don't need to focus or don't need to worry about it. Just focus. Okay. Then we have to mention some sort of entry point. Here is an interesting thing. We will also learn about entry point and CMD. Okay, you just need to understand, okay, there's some sort of commands which need to be running, like here you see run the web server using Flask command. So the command is here in the entry point done. So this is how a typical Docker file looks like. So now it is also mentioned, like you can see, like, okay, explanation of the things, no problem with that. Once it is done, like you have right now the app.py, you have the Docker file. Once it is done, you can just create the image. How? You just need to mention like docker build, then docker file, because you're running the docker file, then -t, then here in testing part you have to mention your docker hub account name, and then / then a custom image name you want to use. Okay, custom image name. Okay, so it might be overwhelming for you. Let me just skip this ones because I'm just going to show you hands-on on it, so you just don't need bother about it. Let's just think about what is happening after we just go for the building process. What happens is, interestingly, every line you have just wrote by now, they are a kind of layers. They're kind of layer, and they build some sort of layers. So you see, from Ubuntu, this is kind of layer 1. This command was like layer 2. This command was layer 3 and 4, 5. Okay, here we have 5 layers, and if you have just looked or worked with Git, you might understand like just like this dot. Okay, these are connected. Now why did I mention about it? Because when you just create this kind of a Docker image, whatever it is, every step takes some sort of space. Okay, for Ubuntu and etc., it takes some sort of space. For the Ubuntu layer, create the OS and so on. For these packages, it takes this space and so on. So you can just look into that by Docker history. Once you create this, or once you build this image, you can just look for Docker history, and then you mentioned your image name as a whole, like Docker hub name / image name, and you can see the size. Okay, you will understand, okay, this is the space it takes. Okay, no problem. Now, but why did I mention about the layers? Why? Because sometimes when you were working with, or whenever, sometimes you are going to create a Docker image, but sometimes you might fail, right? So when it is done, like maybe in the layer 3 it has failed for some reason, maybe internet issue and so on, so it is not going to start from layer 1. That is interesting. What it is going to do is it's going to start from layer 3, because it knows like these 2 layer has successfully been completed, so this will be done. So that is interesting, because this is a layer concept, and we'll learn about it later on. But let's start with this one. I'm just going to follow this one. Let me just skip it here so that it's very easy, rather than keeping it in on my different monitor. Here the course, let me just go for here. I'm not going to follow Mumshad's one. Let me just go for this one. Within this, you see Docker commands. Within that, we have this Flask the app, and okay, so these are the things. So let me just go here, no problem with that. Let me just look for, we don't have anything, so mkdir, let me just go app, no problem. I've just created a folder called app. Okay, and let me just get into it. cd app. Okay, I'm just within this folder, you see, Docker Kubernetes series, Docker apps. Okay, within the app folder. Great. Now my main goal is to like have these files. Okay, in this block I mentioned like there are a few ways to just do it. Maybe you might think like, okay, let's clone this one, or fork it, or give it a star, whatever it is. You can just do that. But the main thing I'm going to do is just going to use the Linux commands and so on. Okay, I'm just going to copy this one. Okay, copy it, group, great. Come up here, and I'm just going to create touch app.py, right? My bad. Great. So then we're just going to vi using vmwaiter. Okay, then I'm just going to paste it. Exit colon okay. I'm not sure if you know how to do it, so I do encourage you to follow my blogs to learn the Linux. Okay, or you can use VS Code for sure. You can just easily edit this kind of stuff. But yeah, why should we go for that if you know about this process? So, and I can also see whatever the content I have within the app.py. You see, this is the content. Let me just clear this one by now, and then I'm just going to create a Docker file and vi. Let me just go for the, I believe here. the Docker file we do have. Let me just copy it, right? Paste. Great. Let me see. Great. Same thing. Now, talking about the Docker file, I'm just going to explain it within a while, but let me just copy these things, right? Then we are just going to explain that. Here, I'm just going to create another file called requirements.txt so that this file is created. And although we can just do it in the Docker file, but it's better practice in the developer world that we mention the requirement.txt so that, and we do run this requirement.txt file and we just do install them. Okay, so let me just clear this one and write requirements.txt. And then paste this one, exit, and let me say escape. Okay, let me just check this one. Yeah, done. That means now if you just go for here within the app, you see there are 3 files that has been created. That's good. Now what's the goal? The thing is, all of these files have been created, but let's just explain what is happening. I am not going to bother about the app.py file. Like, this is a Flask app, right? You just, if you know about it, or if you don't know, you can just ask the AI. But let's talk about the Docker file because it's related to Docker. We're eagerly mentioning, like, okay, I'm not sure if I can say it. Let me do it. Okay, eagerly mentioning Ubuntu. We're just using Ubuntu image, but we're also mentioning the version 22.04. Then we're also mentioning the environment, also mentioning the system dependencies, what we need to, what kind of things we need to install and so on. Then we also have this thing. We have created this opt/source code, this, and then we have just also mentioning this is our working directory, mkd dir. Okay, to create a directory, we just do this one. Will run. Basically, you see, if you just see this one, you see the run, then this. That means basically this is what that is getting used or used in the terminal, and run is basically meaning this will be running here, right? Then you see to copy, then requirement or requirements.txt, then dot. That means we're just copying that. And then install Python dependencies. These are the dependencies we need to install. We also need to copy the app.py. So that means we're copying requirement.txt and app.py within our this folder. Okay. And then we have this environment variables, then expose. We have to expose this port. And this is some sort of, if you have earlier, if you have just followed this video for a while, we have seen that for our MySQL database or MySQL container, we had like 3306 node which was used, right? Or port. Okay. And now this is exactly 5000 port which we are saying like, okay, expose this port because this is where we are going to access this app. Okay. And also entry point. We're just going to talk about entry point later on. But these are the commands basically you can use as a whole. Okay. So this is what it will use, Flask run and this. So you can write Flask then run then this, but you can also use this kind of thing, just like the list, okay, or array, whatever you say. So this was our Docker file, and we have also mentioned about the requirements. That's good. Now we have mentioned this one, so Docker file, app.py, and requirements.txt. Great. Now what should we do? Now what we should do right now is to build the image using the content we have. Right. That's interesting. So what I'm going to do right now is I'm just going to be within the app folder, then say docker build -t, and then my Docker Hub ID name, and then slash this specific, whatever. This is totally up to you, whatever name you want to give it, and then this dot you have to mention because you have to specify from this location. Okay, let's go for that. Okay, slash now the thing is docker build -t whatever we can say. This is customized app. You see, it has started building. So yeah, it's just following the process, and 13 out of 13 is finished. That's good. It is done. Very easy. Then we just need to mention docker. We have to just log into our docker, as I have already done all of the process earlier, so I believe that will be very much easy for me. Like, okay, yeah, login succeeded, because for you it might be something like this one, like it will provide some sort of this, and then you have to log into your docker account. Then you have to provide this code to your some sort of code to your terminal or the website, and then it will be logged in. Once done, then you have to also mention docker push, then the whole like image name consisting your docker hub name. It is almost the same like GitHub, right? Just named as customized. Okay, it's preparing. So what if if I want to verify? Now here, if you just come up here, what you can see right now is, you see updated a minute ago. So it is exactly the same app I've just created. Okay, so that means this has been pushed. So we've successfully created an image, because right now if you because it's basically Docker Hub, so it's public as a whole. So if you want to use this image and want to run the container, you can just simply mention, instead of like maybe docker run nginx, you can mention docker run then Mithul3131, then slash you can just mention customized app. So that will be running in your local system. So that's good, because obviously it has to be public, and it's public right now. So yeah, that is how we successfully can create these ones, an image, and run that. Okay, so this is what it is. Now talking about the environment variables, earlier we have also mentioned, you see, when talking about the MySQL container, we mentioned about the password, right? So this is how it is. So if you have to mention about the any specific thing you want to change, for example, the color is set as color equal os.environ.get app color. So if you want to like kind of change it from outside, whatever it is, like when you are running it, you can just mention like docker run -e environment app color equal blue. So once it is done, so you see this, it was mentioned like app color, it is looking for a variable, so you have passed the variable value as blue, and when you are running this docker run environment, and this is the some sort of container, so this is not existing for you, this resource is not available for you. Just assume that this simple web app color, this is an image which basically looks for a value called app color in or some sort of variable, and once you are creating that, you just need to mention. So this is how we pass it, and we have exactly seen the same example earlier for our MySQL one. If you just look for here, here you see environment a variable we have used to have passed this one, because it is expecting this kind of things. Okay, this is how we do that. So I believe that should be enough. This is enough, because yeah, we can just change it, and then these things will change. Then why content exists so fast? That is the thing. Also, I also mentioned, right, like it exists. Now the thing is, why? Because the containers were like, the concept came like, okay, the contents are expected to be deleted, because like contents were, when it was created, it was expected like it should be doing some sort of task. Once the task is done, it should be gone. So this is why the containers do exist so fast. But while talking about these things, there are some sort of things we need to also learn, because you see CMD for the Ubuntu, for example, we have also worked with Ubuntu, right? That's interesting, right? We have worked with Ubuntu, but we haven't mentioned this specific version for, but we have used the latest one, right? But when we were running the Ubuntu, we did mention some sort of command, right? Docker run Ubuntu, then sleep something. But in general, what happens is when we run the container, it is expecting some sort of like bash. Okay, it's expecting a bash. Now this is something I have like told you to practice, I believe. If I just look for here, with Alpine, I believe I've seen that. Yeah, here you see Docker and IT Alpine bean sh. When you do that, you see this is something that pops up. So yeah, so you can just look for it. So it was for Alpine, but then again, this is how the Ubuntu is something expecting like that. So it is expecting CMD. If it doesn't found, like here you see CMD defines what commands is to run, but we have a bash, a shell type. Bash looks for a terminal to work on. If it can't find it, it exists. So we have to mention that. Okay, so there are a lot of things. It might be overwhelming for you, but for example, I'm just going to talk about the sleep command so that you can understand it properly. So assume now that you want the Ubuntu to sleep for 5 seconds every time it's launched. Okay, so just assume that and you see, like from Ubuntu CMD, these are the things what we run or write on our Docker file. So assume that I'm just going to create a Docker file which is basically for our Ubuntu, and I mentioned from Ubuntu CMD is at the last. Just in the mean, there is obviously some sort of code and others. Just let's skip for a while. And the CMD, we are expecting it to sleep for 5 seconds, so we can mention it in the Docker file. If it is done, we don't even need to mention in the, just like that, Docker run Ubuntu sleep 5 seconds. We don't need to mention that. It will automatically follow this process because it's written in the Docker file. Okay, now that's good. So you can mention just like that, the sleep and sleep 5. That means this is exactly the command it will follow. But instead of writing, like now assume that you want to increase the sleep time to 10. Like for example, now like you have created the Docker file, no problem, and you have mentioned sleep 5, that means 5 seconds. But right now you have thought like, okay, we have completed the Docker file, it is up and running, but I want to increase the sleep time, maybe 100 seconds, maybe 10 seconds, whatever it is. I want to customize that. To customize that, that's a different point. Now assume for that you have to use entry point in your Docker file, so that once like you see Docker run, for example, assume this Docker file is basically part of Ubuntu Sleeper. This is the image we have created and it has entry point sleep. Okay, now Docker run and the image name. After that we have to provide the value of this thing. If we write something in the entry point, the value for the entry point or command is given here. So this is how we can do that. Okay, rather than this, because if we just do that, it is fixed almost, right? It is fixed, like okay, CMD say 5, that means it will sleep for 5 seconds. But if we go for that entry point, we can customize that. What if the person doesn't person is the newbie and don't know like how to run it? Just the person just starts with Docker run Ubuntu Sleeper. What if we can the person can do that? But in this case, if the person has like CMD sleep 5 and entry point sleep both in the Docker file, it is perfect for them. If this is there, so what happens is when the person forgets to give a value for 10 or value whatever it is, any value out here, it will basically look for the CMD command, and you see it is written sleep 5. That means it couldn't find the value for this command, then it will go for the CMD, and CMD has a command, it will just follow sleep 5. That means it will sleep for 5 seconds. So by default it is going to follow the CMD. Great. Now let's talk about another thing. That means is Docker Compose. For example, assume there is like 4 containers or images we do have, and we want to create the containers. So every time we want to do that, we just write in Docker run, Docker run, Docker run. Okay, it's like overwhelming, or it's like repeating things. So it's not a good practice, right? Rather than this, like what you can do is you can use docker compose.eml file. So this is some sort of YAML. We'll just talk about YAML in our Kubernetes series. So we have to mention like as we can just run them as service. So you can call like within the YAML services colon then web. This is our web app. So web app image is MongoDB. So this is our database. This is for messaging and this is for orchestration. We just mentioned this, and within that we have also mentioned the image. Okay. So these are going to be like the containers and the images. Okay. Web container, database container, messaging container, orchestration. And once it is done, we just need to mention the YAML file name and then up. So all of those are going to be running up and running within a while. So this is a practice, and let's talk about a good example, sample voting application. This is very famous one, and yeah, you just use this one from here and you can just run it in your local system. That's very cool, and I do believe this is something should be an assignment for you guys. If you're just looking into this, just go for this one and you just follow the readme and create this voting app, and it will be very awesome for you. You can just run it in a local system and you can vote for the thing stuffs like vote for whatever you like, and you'll see the results as well. Okay, maybe you can create an election, small election in your family, like okay, who is most famous in your family. Okay, let's look for that. Now let's look for this thing for an example perspective. Like assume that there is a for voting. What happens? We have a voting app, and whatever just the voting app's main responsibility is to take the vote, right? And then it stores them in a memory, and there is some sort of worker which is working in between, whose main responsibility is to take that from here and then pass it to the DB, which is again working with the result. Okay, no problem. So those who are like very much like eager to like know about, okay, who is much more like if you're a cat person or dog person. Okay, so maybe you can select this one, cat or dog or something, for example. So this might be the vote application interface. Okay, you can just choose a cat or something. Okay, once done, then the data is passed through to the Redis, and then once done it goes for the worker, and it's some sort of net and once NAT, and once it is done it goes for PostgreSQL, and once it is done the result is passed through this sort of interface. Like maybe okay, cat has owned 100% of the people to like it. Great. So this is how it works as a whole. So yeah, you can check this out, check this one, and I have actually explained like how to run this one. Like for example, if you want to create every container manually, like using docker run, you can do that, no problem with that. Again, we can use docker compose as well, so we'll talk about it later on. But just to give you a hint, I've also mentioned it here, but first of all, here the Redis, like you see, using the Redis image, Redis container, the container name is Redis, has been created using the PostgreSQL or Postgres image. The DB container has been created using the voting app image. This vote container has been created, and interestingly, you understand the port mapping right now, because you see 5000 and :80. That means 5000 is in a local system, 5080 is this container which it is exposed to. And link, this is an interesting thing that we haven't talked about. Link is something it is expecting. And now here you see, just to understand what's happening, or this is how we are going to, you see, we can create these 4 containers, but you also need to understand, like we have to link everything, right? So that once it gets something, it passes this to this. Once this gets something, it passes this to this. Once it gets something, it passes this to DB, and this passes to the result, right? This is how it works. So this link, like this code, as I mentioned earlier, this sample voting application, if you just go for that, you will see the codes out there, and there is within the like vote apps, like okay, slash like vote slash app.py. So here in the get Redis, this is basically specified that the host it is expecting is Redis, some sort of that. Okay, so this is what we did. So first of all, we mentioned this Redis. You see, this is the container Redis, and after that we also mentioned the host it is expecting. This is basically because this is actually this is how the code was written, and that is why we are just linking this in this process. Okay, so because if the code was for this one, so it is expecting something called Redis, and it is Redis and is connected with it. Okay, this is how it is. This is how we can do. So for this to connect this one, we can just do this one, and you see everything will be created, and only these two will be connected. Now if you want to connect these two, you just need to follow this process. Again, for this DB, like for this result app, in the code of result app, if you just go there, it's basically Postgre then @DB. So it is basically looking for this DB. So that's why we have mentioned DB, because from this, and also mentioned DB because that is one of the reasons, because as the codes are something like that, that's why this container name has been written like that, so that it can just follow the code. Okay, so there's no specific reason like why this container name is just like that. The reason is basically just the code. Okay, I just wanted to make you understand like okay, why or how this link came up. That's it. So once it is connected, that's good, it's done. And then once these two are connected, then we need to also connect with this worker with this Redis, and this worker with the DB. Again, in the code, the Redis and DB was mentioned specifically only for this project and not for this, but yeah, I hope you got it. I've provided the link there. So it is very famous one. A lot of the folks like have learned from there. So you can just follow this one and done. So once done, every like 4 of them are connected, and you just follow this one. So you have just started the containers, you have just connected them. Now you just enjoy the project, right? That's good. Also, rather than creating everything manually, what we can do, we can just create a compose file, and you can mention Redis, the image, then Postgres, and it's maybe the version you want, voting app, image, and the ports. Okay, because it's like the port binding, right? And the links are basically for the dependencies, because these or connection, sorry, not dependencies, the connection, because the voting app was connected with Redis, right? This is how you write this compose one. For the result, same, it is connected with DB. For the worker, it is connected with Redis and DB, right? We've just seen it from here. Great. So this is how we can just follow the format, right? But also, if you want to build an image instead of pulling an image, we can do this. There's the difference. Build an image instead of pulling an image. There are a lot of things: building, pulling. So once we are creating something, we're building. Once we have already done, we have already created something like that, the image, we're just pulling that. So this is the thing. Okay. Yeah, here is the difference. Like in the left, we can see the images, and for the building here, all of the things are built. That's it. Again, talking about the versions, for the Docker versions, for the Docker version 1, what we had to do is we had to use the link, and we had to mention specifically the link one. For the Docker version 2, it was not like that, like a nate and name. For the Docker version 3, from there, we have just started looking for the depends on. Now the link has been transferred to depends on, something like that. So it will be like rather than link, we're just using depends on. Okay, so we have to, you can just look for that. Okay, the version, these are the things, basically it depends on the version. Again, Docker network. So for example, assume this is a network or traffic that has been created. So if this traffic is created, it will be connected with both of these two, and if the backend traffic is created, it will be connected with everything. 1, 2, 3, 4. Right? So So not like everything, but as a whole, like, because as connected with front end, so front end is connected with both of them, so everything. These are not that much of necessary stuff, but just talking about how this network stuffs work on, because obviously once you have connected, then you have to obviously deal with the network as well, backend and front end, because you are creating a website front end and backend, and you have to deal with the traffic from where we are passing the data, because we've created the link, we've created the containers. Now we have to deal with the traffic. So from here, the Docker Compose, these should now look like service networks. You see, earlier it was just our images, right, or build, whatever it is, if you want to build it. Now we've also mentioned the network, which network it is part of, right? But interestingly, we haven't created the network from scratch yet. So we are just assuming it is existing, so no problem with that. So we also have to mention, like, okay, this is it was in the node, basically in the version 2. For the Redis, you see the Redis is part of backend. Okay, you see the networks is backend, and for the DB it's a part of backend, and for the vote, part of front end, and again backend. Okay, so yeah, this is how we do it. And also we have to mention the networks, which two networks we do have, front end and backend. Great. So yeah, that's it for this blog. But are we going to end with this blog? No, we surely are not going to end with this blog. I'm just going for the blog 2. Okay, once we're done, yeah, I've just found our blog. So this is going to be very much, it's not going to be technical, it's just going to talk about the theoretical aspect, and we're just going to move very fast. It's very small one, so yeah, that should be enough. Okay, let's talk about this. So for example, when you are actually downloading Docker CLI, REST API, and Docker daemon is getting installed. Docker daemon basically like manages the images, containers, volumes, etc. in the background, and Docker REST API is basically used to talk to the API and and work with the daemon. Docker CLI is the command line where we work, because you see we were working the Docker CLI. Now the thing is, sometimes it can happen that the Docker CLI might be in different space, but and Docker engines, like these two are in different space, so you can just connect with them. So you can do that. So we can just connect with them, and we can just work with it, no problem. And talking about the containerization, Docker uses namespace to isolate workspace. So that's interesting, because we will be talking about namespace in Kubernetes. And yeah, namespace is basically to isolate the workspace, you see, process ID, network, etc. by creating their own namespace, thereby providing isolation. Okay, so this is almost the same concept that's what we are going to use in Kubernetes. So yeah, that makes it different, like for a specific task. And interestingly, talking about the CPU and other, this is very important concept we are going to learn later on in Kubernetes as well, how we can limit those stuffs. We're just going to code that down hands-on. We'll have hands-on, but right now I'm just not going to talk about this Dockers, how we can do that, because it's much more, because in industry we're much more dealing with like Docker and the pods and so on. So yeah, sorry, Kubernetes. So yeah, Docker is something we'll just learn about the theoretical aspect right now. I will just see the hands-on in our later videos. Okay, you see, in a Linux system or wherever you are, we have a CPU, we have a memory, and for example, we just assume that we don't have anything, we just have CPU and memory. And on top of that, for example, if you have Docker containers, they're just taking some sort of your CPU and memory storage. They're for sure using that memory or CPU. Now, if you just don't limit them, like how much they can access, they can actually use the whole memory, and your PC might hang and so on. So what you can do is, like, once you are running your Ubuntu or whatever container you are running, or image, you can say. In general, Ubuntu is basically the image, and once you are creating the container, it uses the same name. That's how it works. You can just specify how much space it can use. For example, here it can use 50% maximum, 50% of the CPU. And if we specify the memory, 100 megabyte is maximum we can use. So we can just specify that. That's good practice. and we learn about it in our Kubernetes series. Also Docker storage, that is something very interesting, because by now we have already gone through a hands-on which had these MySQL. Within SQL we had dash bar, slash var slash lib slash something, right? So in general what happens is when we install Docker, it again has some sort of this kind of format where it stores all of the files. You see within that it has this kind of files, containers, image, volumes, and so on, right? This kind of things within that. But how does it store them? Let's see how a Docker file works. Within Docker file, you see, like it is like from Ubuntu, then we have this running apt command, and then we have to install this and then copy entry point, Docker build Docker file. Like once we're done with the Docker file, then we call like, okay, let's create it and create an image. So we build this one, and it follows this layer, right? This is 1, 2, 3, 4, 5, these 5 layers. So you see we have 5 layers, and every layer has some sort of memory address associated with it. Now once the Docker file runs, it creates some layers. That's good, right? It has been created. Now for example, you have decided to create another image. You see name is my custom app2, but almost the same command. We're just using maybe different perspective where app2, yeah, we're just using we're just copying just app2.py and just this one. These two are different, right? So you see the exactly same commands are out there, 2, 3, these 3. So what happens is when we are building this image, it just follows that, okay, we have already this layer created, like from Ubuntu, there is a layer called from Ubuntu or base Ubuntu layer. So we just don't need to take any more space from the local system. So it will take no space, because already this 120 MB space is there, has been taken, and it is existing, because yeah, it's like okay, it's almost like a home. Okay, a home has like maybe for you family, you have a father, mother, you yourself, and your younger sister, and maybe an younger brother. So in total it's like 5 members, right? Now for every like your father and mother has built a house, okay, with maybe and these 3 are meaning the house. Okay, so now once a person talks about you, like, okay, where is your house, or how have you built it, or what is your plan to create a house, you will say, okay, I already have a house, right? This is how you are going to approach. So this is how it works, because it's existing and you have that. So these 3 layers are not going to be used or getting created, because yeah, they're done, because now these 2 will be there, because these 2 are not matching, right? Yeah, these 2 matching layer will be created. So this is how it manages and works with this layer. Now talking about these layers, interestingly, once we are creating an image, these layers are created. Now this is how you have to understand, because so far when we were basically talking about our images, because like Docker and Ubuntu or something like that, we have just used that for now. But when the Ubuntu was also getting created, there were some layers that has been created, right? But we can't modify those layers. That's interesting. That's the important part, because like for example, I have also created like this one, right? This customized app. So while creating that, I had like 5 layers. So if you want to use this one, you can't modify those 5 layers. On top of that, you can add your own layers, own codes, own things in the Docker file, for sure, no problem. But you can do that. You can do for those 5 which were used to create the image. So this is what it is. So those 5s are basically read only. You can't basically modify them, but on top of that, you can create your own. No problem with that. Also, sometimes like files, like for example in the read only, or in the we had the app.py, so you can't actually modify them, but you can create a copy of that. Like you can create a copy of that in your local system, and you can just modify them, no problem with that. So this is how it works. Now this is what we were focusing on, basically how this thing works. So you see this folder or this system, the Docker volume, like we can create a volume within for the Docker, like var. lib slash docker. We can create a folder called data volume. We can create that, no problem. We by default it's like this, right? By default it's like ops, containers, image, volumes, but we can also create a folder, no problem. Docker volume, create this one if we are within that. Okay, so sorry, my bad. And yeah, here data volume, so this is exactly the name, MySQL image layer. On top of that we can then run the container and keep the volume of the container connected to the volume we created. So now why am I sharing this? Because what is happening is, you understand that this Docker, or for example, once the Docker was created, whatever volume it is associated with, it is etc., it is basically within this volume. Now understand it properly. Like for example, you have installed Docker and you have installed containers and others. So and a container like MySQL has some sort of address where it should be there. So basically that address is basically referring to this volume. Okay, you understood, I believe. So once the MySQL container is deleted, that will be that portion of from this volume will be deleted. So whatever is happening within this Docker location within this volume, that file is there. So just like the volume mounting, what we can do is we can just create a data volume within this file, no problem. We can just create that within the Docker, because once we created the Docker, or sorry, we downloaded the Docker, this was created, so we can just get access to it using Linux or whatever. So we can then connect this volume to this. Okay, if you just can connect just like the volume mount, like you see -b and our volume, the specific one we created right now, data volume, and then the containers volume, because as I mentioned, Docker is basically what we installed, and once we install Docker, there is a specific place where all of the containers, volumes, etc. is there. Like it is not like the MySQL is already there, but when we install the MySQL one, it gets into that place. The containers information is saved there, the volume information, whatever it is saved there, or the location is basically there. So yeah, you can just use the location then, right? For example, here you see for our MySQL, it is like var/lib/MySQL. Interesting, just understand, because var/lib/docker is where the Docker is. For the MySQL, it is in MySQL. Great. And this is basically the place for the volume. So we can just connect it with our var/lib/docker/volumes. We can just connect with it. I think I'm just mistaking. Oh yeah, with the volume we can just connect it with this one. This is something basically we can create our MySQL and we can just connect. Yeah, that's not very within the Docker volume. We can just get this one. So it's basically whatever it is, we can just referring it to vice versa. That is like in the MySQL, just understand here, Docker run v data volume. So you see what is happening. We've created a data volume 2 named folder, whatever it is, not here though, we can see. And we've connected MySQL's this var/lib MySQL. We mounted that here. Okay, we mounted that here, no problem. Then we can, in this image, this is not exactly the same, but yeah, I believe it should be, it might be a mistake, but it should be maybe data volume, because we can mount that to here. So that is what I was talking. Just let's forget about this one, because this is not exactly what it is referring to. In the Docker, in the volume, that is where the volumes are in general. But we can also create our own volumes within this folder and then connect this folder with our containers volume, so that now the things are going to be saved here, just like we did earlier in our in our demo. And it's called volume mounting. But if we do it differently, like outside, then it's called bind mounting. Earlier we did mention this as volume mounting, but yeah, there's a difference, so that we are now specifying. Now you see, right now, if you disconnect this MySQL's volume with, like maybe there is a different folder, that is not part of Docker, maybe a different folder outside of this Docker in your local system, and you have just created like data/MySQL named folder. Within, you just connect with this. So these kind of things which is not within Docker but outside, but you are still connecting with the volume, is called bind mounting. Great. So yeah, this is how we can do it. Same thing, same for process, but yeah, the naming is different. Now talking about the networking, we have also seen these kind of things earlier, the front and back end one, right? So yeah, once you are installing Docker, bridge, none, and host, these are there. You can just follow this one. You can just see like which one to use, which one to do. Like for example, if you just go for the bridge network, it might be used in like here, the Docker 0. This might be a bridge network. It might be connected with our containers. Great. And you see it has some sort of IP, right? So it has some sort of IP, right? Okay, it can be connected and it assigns the containers its internal IP. So, and they can now communicate with them. So you can see 172.1 17.0.1. So once it is connected with the containers, it is like, okay, within this, it is part of a subnet, something like that. So 0.1, so it's 02, 04. So they can communicate with each other then. Talking about host network, it's like, okay, you can run your containers basically on the device's port rather than on the container's own port. Previously we didn't have this option, but we had a specific port of the container where we could access the container and then used to mount the traffic to our local device, just like port mounting, container port mounting. Ubuntu, this is the host, but we don't need to do that now. We can just use devices port to access the container. So it's exactly the same thing. There is also something called none. So it is basically if we connect our container to a none network, it is isolated and runs without getting connected to anyone. That is the thing. It's not that much of concept we need to worry about, but yeah, we can just learn about it. Also, user defined network, you can also create your own user defined network rather than this tree. No problem with that. So yeah, by now, like these are the bridge networks. We had like something like that, like 172.17.0.2. It's 01, 04. So they are connected, and these are almost same, like 182.18.0.3. The same, they are connected. So you can create your own network, like you have to mention driver, is it a bridge or host or none, then the subnets. Okay, now you can also say like what is subnet. Now you see subnets are basically, for this one, the subnet is 172.17.0.0. Then now how do you understand the subnet? Subnet is basically, you see the range, right? You see like it is 172.17.0.1 and it is 0.2, 0.4. So this is within a range, and you see there is a similarity, right? This is basically subnet. It was mentioned once this specific bridge was created, and for this it was 182.18.0.0. This subnet was mentioned. So this is how the range is, like it is 0.1 and 0.2, 0.3. So though this is the thing. So once you are creating your own network and you are mentioning this is something like bridge, and bridge has some sort of subnet, you see, because it assigns these containers some sort of IP address, something like that, within the subnet. So if this is created, the name might be custom isolated network, and this custom isolated network might have the IP address of maybe 182.18.0.1. Then if any containers are there, and remember earlier in the blogon we didn't mention how to create a network. Rather we were thinking like we have networks and we're connecting our containers with it, but this time we are just creating them as well. So once we're connecting our containers with like assume custom isolated network, those containers will have some sort of IP like 182.18.0.1, 0.23 or something like that. Okay, this is interesting because, and after that 16 is mentioned here. So 16, 24, whatever it is, by that number we do understand how much capability, how much containers we can assign to this specific network. So there are a lot of things I'm talking right now. Maybe you might not get a like, okay, whatever, what is this guy talking about? If you have talked about computer architecture course, you might have learned about it by now so far. So yeah, this is how it works. So we can create our own network, and if it is bridge, we obviously need to mention the type and also the subnet, because bridge has that quality or that feature in the name. So yeah, and you have been given a task and the code for that, and how to connect to containers. We have also mentioned that how to connect to containers out here. Yeah, that's the thing. And Docker registry, we have to end with the Docker registry for sure, because once we are creating a container using an image, a specific image, basically you see we are running Docker run nginx or Docker run ubuntu, but from where it is coming, right? Once you are mentioning the image is basically nginx, it is basically some sort of docker.io/library/nginx. From the docker.io, this nginx image is searched, and once it finds out the official one, it just downloads that in your local system. And you can also these are like public one, Docker.io and others, or you can create your own private registry, and you can also download the images or pull the images from the private one as well, following this concept. So yeah, I just don't want to illustrate more, but prior to like end this one, in this session or video, I just would like to say like, okay, we're just going to start our Kubernetes series from later on. So this is the thing, container orchestration. Like we have just talked about the container, right? But containers, health, status, and a lot of things, to mention thousands of containers, we basically deal with Kubernetes or Docker Swarm. But Kubernetes is the most famous one. So yeah, we'll just learn about Kubernetes. So yeah, thank you so much. And if you have liked this video, feel free to share within your friends. And yeah, thank you so much, and feel free to subscribe to the channel so that you can learn the Kubernetes and prepare for the 14 certifications. So thank you so much. Hope to see you in the next video.